Hi, in this video we're going to reason about the number of points of intersection of two graphs using the discriminant. So we've got a straight line with this equation and it touches the curve with equation y equals 2x squared plus 12px plus p. So we kind of sort of try and visualize what's going on. You've got some quadratic like this. So this quadratic has the equation y equals 2x squared plus 12px plus p, and then you've got some straight line, y is equal to x minus p. So it might be like this, for example, a straight line like this, and we've got the equation y equals x minus p, and we're told the straight line touches this quadratic curve. And what's the implication of that? Well, if it touches it, it means there's only one point of intersection. If it says it doesn't cross it at all, so this straight line never crossed the quadratic, then there'll be no points of intersection. But if it said it crossed it twice, you're going to get 2 points of intersection like that, basically. So it means that if we were to try and find this point of intersection, we should only get one. Now, what would we usually do to find the point of intersection of two lines? Well, we basically try to solve the equation simultaneously. So we try to solve this equation and this equation simultaneously. Now, it's already in the form y equals something, y equals something. So we can therefore equate these two to solve simultaneously. So we're going to write 2x squared plus 12px plus p. And that's equal to the y value of the other line, which is x minus p. So let's try and solve that. We want to get 0 on one side, so we have 2x squared. We're going to subtract the x term, so minus x, and then we're going to add the p, so plus 2p. And then if you just factorize out this x out of the middle two terms, the reason is that we want to have the equation in the form something x squared plus something x plus something equals 0. Now, let's remind ourselves from before, we've got this little box here. If you've got an equation, quadratic equation in the form ax squared plus bx plus c equals 0, then if b squared minus 4ac, which is known as a discriminant, is less than 0, you have no solutions to the quadratic. If the discriminant is equal to 0, you have equal roots, which is another way of saying you have one distinct root, because the two roots are equal, then you only have one distinct value. And if the discriminant is greater than 0, you have distinct roots. Now we have equal roots, one solution here, because there's 1 point of intersection. So that means that b squared minus 4ac is equal to 0. So what is the a, what's the b, what's the c here? Well, the a is this value here, b is this value, c is this value. So this is, this is the a, this is the b, this is the c. Okay, right, let's substitute that into our equation. b is 12p minus 1, so that's squared, minus 4 times a times by c equals 0. And then let's just expand and simplify this. So we're going to have 144p squared minus 24p plus 1. That's the squared bracket. And then we've got minus 16p equal to 0. Then that's going to be 144p squared minus 40p, if we collect like terms, plus 1 is equal to 0. And then I would just use your quadratic solve in your calculator for this. So if I go to, on my particular one, I'm going to go to the menu, I'm going to go to the equation solver, and that gives you solutions for p of a quarter and 1 over 36. So p is a quarter or p is 1 over 36. So that's the solutions to this. So there's two different values of p actually, where you're going to get just one point of intersection for these two graphs.